Well, let's get started. I do have an empty Python file that I've set up, and I did set up my OpenAI key and all that, and just loading it from the environment variables. But let's go through the docs. Oh, before I do that, let me just quickly show you. I think it was this one. So I've been playing with. So OpenAI released some updates to their audio transcription API. So what you get this time is they added a support for. Let me zoom in here. So instead of just getting the transcription back, you also get individual words if you want to, and you get timestamps where those words occur in the video or in the audio. So let me show you. I was playing with it yesterday a little bit. Let me just see, where did I? Oh, it's here. I'm just starting. So there's the server side, I guess server side, if you want to call it that way. It's fairly straightforward. Let me see. Transcribe, right? Is it transcribe? It's the same. There you go. Right. It's the same thing, similar API as it was before. They added this timestamp granularities. So if you set this to, I think it's either word or words, I don't know, you basically get this back, right? So what I did, I just open it up. Go. So this is the video that I transcribed. The transcript is down here. So what you could do is, I just pause or mute that one there. So I could click on the word, and it's actually going to jump. See down here, right? It recognizes the word, and then it actually goes to this timestamp in the video. So it's pretty nice. You can do a lot of interesting things with this and play with this. All right. Anyway, let's go to the LlamaIndex and see what that's about. Let's go here. And if you're joining for the first time, I've been doing these, I would say, for a couple of months now, every Saturday. This is all unprepared or unscripted. I try not to look at the thing during the week that I'll be looking at on Saturday. So it's going to be more exploration. If you're looking for like hand-holding tutorial style of video, I have to like disappoint you. It's not going to be that. But all right. Anyway, let's take a look what LlamaIndex is. So let's do platform. So you can turn your enterprise data into insights with Gen AI. Okay, so that's the platform that they're assuming selling. There's something called Llama Hub, but there's something called templates, and then they have Python and TypeScript libraries. We'll go with Python. Okay, so that's just the repo. So let's look at the docs. All right, so let's look at this and see what this is. So LlamaIndex is a framework for LLM-based apps to ingest, structure, and access private or domain-specific data. It's available Python and TypeScript. So LLMs, natural language interface between humans and data. Widely available models are pre-trained, yes. However, while they are trained, they're not trained on your data, of course, which may be private or specific to the problem you're trying to solve. It's behind API, SQL, yep, so different sources. So you may choose to fine-tune an LLM with your data, but training an LLM is expensive, yes. Due to the cost of training, it's hard to update an LLM with latest information, yes. Lack in observability. So when you ask an LLM question, it's not obvious how the LLM arrived at its answer. All right. A couple of weeks back, I was looking at LangChain. So LangChain has some observability built in, or I guess it's a service, Langsmith, I think they're calling it. So curious to see how this one is different. So LlamaIndex takes a different approach called, RAG, Retrieval Augmentation Generation. So instead of asking LLM to generate the answer immediately from the data that it has, LlamaIndex will retrieve the data from the sources that you provide, adds it to your question as context, and asks the LLM to answer based on the enriched prompt. So this is similar to what LangChain does. It's similar to what EmbedChain does. I think EmbedChain, in majority cases, wraps LangChain anyway, right? But basically, this is what it does, right? So you say load my data is whatever, right? This is my data here. So you load this, and then what this is telling me here is, so you have a question that you will ask. So you have some query and say, what is the web? Yeah, let's do that, right? So that's the query. So what this does is it's going to basically enrich the prompt, right? So you can think of this as your prompt, like user prompt, but the enriched prompt would be something like, I'm guessing, right? Would be something like this. Answer the following question. Let's say answer user's question based on the provided context, right? And then you would do context, right? My data and question is whatever that query is, right? Let me see if I can break this up into multiple lines. Do it something like this, right? It's just easier to read, nothing else. There's no logic here, right? But yeah, so enriched prompt would be you basically answer user's question based on the provided context. The context that you provide is that data. That's the LlamaIndex is going to go and retrieve the data, and then you pass the question. I guess this would be query, right? Query, and then you could probably do something like, right, answer, and then you send all this to the LLM, and it's going to spit out the answer, right? So RAG overcomes the weaknesses of this. So it's cheaper than fine tuning, right? If you go from if you think about the list of, I guess on the scale of cheapest to the most expensive way how to do all this is, first is playing with prompts. You can get far with just tinkering with the prompts, making the prompt better without fine tuning on anything or anything like that. The second is you do RAG, right? You provide the data and say, hey, answer these questions. Don't forget what you know about, but use my sources of data and then answer it based on that. Right? So that's second one. And then the most expensive and time consuming would be fine tuning, right? And on your data, right? And that is expensive and takes time. All right, so RAG overcomes the three weaknesses. There's no training, right? So it's cheap, of course, compared to training. Yeah, data is fetched only when you ask for it, so it's always up to date. LlamaIndex can show you the retrieved document, so it's more trustworthy. Okay, yeah, so you can get the documents, right? I've seen this I did the Pinecone episode where basically you chunk the documents, right? You create embeddings and then store it, and you can store those embeddings with some metadata, right? That's the nice thing, right? You could do, let's say this is my data here, and then you would have, I know I'm just making this look ugly, but you could think of your data being something like this, where you have metadata. And then in the metadata, you could have like a source or author, whatever your metadata is. And then when you store this data, you would basically create embeddings and store this, but also store it together with the metadata. And what you can do then is, when you do this enriched prompts and when you query the LLM, you would get the answer, but you could also say, hey, also return the metadata. Tell me whatever the source was, whoever the author was. Right, so that's pretty powerful there. Yeah, so it can show you the retrieved documents. So there's no restrictions on how you use LLMs. You can still use LLMs as autocomplete chatbots. Yep. Use cases on the left. We'll take a look. Only makes LLMs more relevant to you. All right, so how it can help. So it does the data connectors. Yep, so different sources, data indexes, so you can structure your data. Okay, so it's easier to consume. Engines provide natural language access to your data. So query engines are powerful. Okay, chat engines are okay. So that's the two different ones that they like differentiate. Data agents are LLM powered knowledge workers augmented by tools from simple helper functions to, okay, we'll see what that is. And then app integrations tie LlamaIndex back into the rest of your ecosystems. This could be LangChain, Flask, Docker, ChatGPT. Okay. Who is it for? Beginners and also for everyone. There's a high-level API for beginners, 5 lines of code. All right. I mean, that's nice, but you don't want to get like you don't want to abstract too much either, right? Because in a lot of cases, if you abstract a lot of stuff, yes, it makes it easier to get started, but typically that basic scenario is not what people are looking for. So you're kind of making it also harder to customize, depending how it's done. All right. So there's a library, pip install. Okay, recommend starting at how to read this docs. Yes, that's what we'll do. I'll open it there. And then GitHub, NPM, there's community, Twitter, Discord. So there's Llama Hub, collection of custom data connectors. Okay, so that's what Llama Hub is. And Llama Lab, ambitious projects built on top of LlamaIndex. Okay, we'll check that out as well. All right, let's do, what is this? How to read the docs. Okay. These are, I like these docs. They're very structured so far. We haven't gotten to any of the code, but so far it looks fairly like structured. So you should have Python, yep. So they have notebooks. You can try. Yep, they have Google Colab. By the way, if you haven't tried Google Colab, it's pretty nice. It allows you to run Jupyter networks, and you can run them on like GPUs as well. And there's a free tier, so you don't have to pay for anything. I think you're limited by, like, there's a limit, of course, on the free tier, but you can also pay. I remember a year ago, I got it for a couple of months. I think it was like $20 or $15 per month to get the next tier where you get more GPU time, I guess. All right, getting started. Okay, so there's nothing there. So let's do start a tutorial. Make sure you follow the installation steps. Okay, so installation steps were, all right, there you go. So installation from pip, that's what we'll do. So let's do pip install here. If you're watching, did you try this before, or let me know if you've played with this before or any other libraries. Okay, so we have this. Let's also upgrade pip while we're at it. So it may download stuff. Okay, all right. So important. I will use OpenAI. So by default, we use yes. I do have this set up. Okay, so you can also use other LLMs. I don't know. Yeah, so you can use other LLMs. I'll just stick with the default OpenAI. If you don't wish, you can use local as well. This is interesting. I don't think my laptop could handle streaming, me listening to music and running a model. Hey, Marino, thanks for showing up. So yeah. So let's see. I'm not doing the local, but I guess you could do the local as well if you want to. Right. What else? Oh, install from, okay, install from source, etc. So OpenAI starter example. I think that's the one that I was at before, right? So we did this famous five lines of code. Okay. Download. Okay. So this example uses programs. So we need to download some data. So let's do that. Oh, it's just the essay. All right, I'll just do this. And they said it's in the data folder. So we'll create a new folder and Paul Graham essay.txt, paste it in here. So we have the data. Let me close this one. We have that. I do have OpenAI key set. All right, and we'll go through subcode. So, oh, did I paste it here as well? I didn't mean to do that, but okay. So let's clean this up. So the only thing that I'm doing here first is just loading my environment file. That one has the OpenAPI key set. So in the same folder where we created a data folder, in the same folder. What? Oh, in the same root folder. Okay. Starter. So we'll do from LlamaIndex. We're going to import vector store index and simple directory reader. And we'll read the documents. So data, load the data from the folder, right? It's going to load everything since it's a directory reader, I'm assuming. And then we'll create an index from those documents. So we'll do vector store index from documents. So this builds an index over the documents in the folder. It's just that one text, but you could have multiple. And then you can go and query. So I'm curious so let's run this. I just want to see what this does behind the scenes. So let's do Python main. I didn't call it starter, just calling it main. All right, so let's take a look. So these are all the documents. I'm just printing all of them. Maybe I should just print a couple, but I wasn't sure what the format is. So documents, so there's an ID. There's no embedding. So there's the metadata I was talking about earlier, right? So there's a file path, file name, file type, file size, date, last modified, blah, blah, blah. Excluded, metadata, embed keys. All right, so I'm assuming this is what tells, once you do the embedding, tells you what to exclude, what to not embed, because you only want to embed the content, right? And then relationships, and then there's the actual text, right? And I think it's just one document, right? Let's see. Yeah, I think it just does everything as one. Start character and text template. Oh, okay, so there's some template that they're using, metadata string and the content, and then the separator. All right, so it looks like it embeds each file, I guess, as a document. I just double check that. Yep, just one, and then vector store index from documents is gonna create some index, and I don't know what that index is, but we can take a look. So it's a vector store index. Is there anything there from? Oh, so you can do from vector store, you can do from documents. I can do it as a retriever. I remember this from embed chain, I guess. All right, so this one will then index will probably do the embeddings as needed as well. All right, so we're gonna query the data next. So let's do this. Load the data, and then we'll do query the data. So create an instance of a query engine. So it's index.as query engine. And then we're gonna query it. Engine.query, and say, what did the author do growing up? Okay. And we're gonna get a response back. Okay. All right. So I guess these are the 5 lines of code they're talking about, right? All right. So yeah, so the author wrote blah blah blah. This is just from the text, right? It knows how to answer it. All right, but what does it do behind the scenes? So this creates an engine for Q&A over your index and asks a simple question. You should get back a response similar to the following. Yep, that's what we did. All right, let's try with let's see. Let me use the transcript that I did yesterday, what I was showing you earlier. So let's go, just open that one. So I'll just use this text and I'll put it here and I'll say, I think this is video. It's about a project called Kind. So I'll just call it like that. I'll remove this. Let's scroll to the end here. Just remove that. Okay. And now we have the transcript of a video. And I'll move this out here. So we'll do we'll rerun the same thing again, but over that video thing. And we'll say, what is the video about? So let's see if it's going to know what the video is about. It should. There you go. So yeah, the video is about using Kind for local Kubernetes development and covers 4 perfect. That's exactly what the video is about. Yeah, that's awesome. It did actually pretty good. Let's see if there's, my name is not there, so it's probably not going to know who created the video. It's not going to know who created the video, but it's always curious to see what will, yeah, there you go. Yeah, that's, at least it's not lying, right? I'll take this over LLM coming up with some answer that's a lie. All right, so let's go back to this. So viewing queries and events using logging. Perfect. So let's see what's happening on this. Is really nice. This is, I like this because it does look and feel like magic right now without knowing what's happening. So let's do, and I think this logging is just basic Python stuff. So we're logging to standard out and logging the debug level, and then stream. Oh, we're just adding a handler. Okay. Get logger, new, add handler, streaming, logging.stream handler, system out. Okay. All right. Okay. Can set. All right. And now we could see if we rerun it, we should see what's happening behind. Oh, okay. There's a lot of stuff happening behind the scene. Debug might not be a good choice, but let's see if we can figure some stuff out. All right. Oh, wow. There's. Okay. So first line, debug. So one file was added. It's going to parse it. And it's making a request somewhere, I'm assuming. Yeah, OpenAI request. So it's, yeah, so it's embedding everything, right? So it's embedding the text. Okay. Just see, it looks like it does it in one go. So it embeds, creates embeddings. Okay, so response was returned. I hope I'm not flashing my API key somewhere here in the debug logs. Hopefully not, but yeah, so it got back the embeddings. Maybe let's do info. This is way, like, we're looking at HTTP stuff. Oh, it's just too much. Oh, there you go. This is better. Yeah, so creates the embeddings. It probably does the chunking. right? Because there are two requests, right? You can't send everything. So probably chunks it into splits the content, and then use the completions API. Let's do debug and see if there's if uh, if there's like a prompt or something, if it's going to tell us. So this is the answer that we got back from the completions. Let's go. No. All right, there you go. So this is I think this is the query that it sends. So let's just see where it starts. So request chat completions, JSON. So okay, so there you go. This is the system query, right? So you're an expert QA system that is trust. So this is what gets added by LlamaIndex, right? So it's saying you're an expert QA system that is trusted around the world. Always answer the query using the provided context information and not prior knowledge. This is important, right? Some of the rules: never directly reference the given context in your answer. Okay. Avoid statements like based on, yeah, makes sense, or the context makes sense, or anything along this lines. All right. So this is, as you see, this is the first message here. And then the second one is as a user, right? So we're saying context information is below. And then I think this is just telling what the file path is, even though like OpenAI is not can't use this. I don't think we upload the file, but we'll check. I might be wrong. And this is the actual text, the context, right? And then down here it continues. So given the context information and not, so this is again added by LlamaIndex. Given the context information, not prior knowledge, answer the query, and then this is what we actually asked, right? What is the video about? And then answer it here, pretty much, right? So yeah, if you watch from the beginning, this was very similar to what I was typing out earlier there. All right, so let's see if it does it upload the file. There you go. So embeddings. Let's see. No, I don't think it. No, it just calls the embeddings, right? But then probably maybe stores it locally somewhere, or I'm not sure. Or it passes it to passes the embeddings somehow to the chat. That's what I'm not 100% sure. Because this over here, it does some. Oh, so maybe the LlamaIndex gets the embeddings back, does the actual search, and then whatever it gets back, the top, see, there's like two scores, right? So this is how similar the query is to whatever was embedded, and then maybe it uses that. Maybe it uses that for the context. Might be, yeah. All right. So that was debug, and as usual, my questions will be answered in the next section probably. So by default, the data you just loaded is stored in memory. Yep. You can save time and request by saving the embeddings to disk. Yes, this is what we want to do. So we do the embed the stuff once, and then next time you don't have to embed it again. You don't have to call OpenAI, pay for it, right? You just load it from the database locally or wherever you have the database running. All right, so let's do index. Oops. I hope my laptop doesn't froze. Like yesterday, it froze twice for no reason. Maybe I had too many things open, but all right, so persist the index on disk. Otherwise, it's in memory and you lose it. Yeah, exactly. By the way, like a lot of people ask me about this. It's called Magic Autocomplete. It's not. It's GitHub's Copilot, right? And I don't know. GitHub Copilot. I know you have to pay for it. However, I got it for free, and if I remember, it was like if you contribute to open source, you can get it for free. But I don't know if that's because there you go. Yeah, I don't have that one. There you go. So for individuals, maybe I am paying for it. I don't know. Oh no, there you go. Free for verified students, teachers, and maintainers of popular open source projects. So I know I got it for free somehow, even when it was in beta or whatever it was. But anyway, so yeah, if you're like maintainer, contributor, maybe you can get it for free as well. Anyway, it's pretty nice. All right. So persist. So it will save it to storage, but you can change that by passing in the persist their parameter. Yep. So persisting is not going to help you if you don't load stuff. So this is really nice. Okay. So let's see where we are. We're here. So we're going to, all right. So the first thing that I like here with LlamaIndex is that it feels like there's a single library, or at least single module. I apologize to Python people. I think it's modules. Embed chain, lang chain, there's like gazillion different module names. So far, this is looking good. Only one. You don't have to think through like 5 of them at least. So load index from storage. Okay, and then over here, we set up the thing here, and we'll say, so we're gonna need, so let's do a function. Let's say, so load index, and we'll say so documents. We'll move this up here. So we're going to load the data. We're going to create the index. We're going to persist it. Oops. Oh, too much. One indentation only. So persisting the index, loading it, persisting it, and then I'll say data there. Let's just do data. Well, no, we can't do data. We'll do storage. Okay. Didn't want to copy it, but storage. And then this will be storage. Oh no, this will be data, right? So we'll do storage there, and we can do data there equals data here, just to make it a little bit cleaner, right? And then over here, we can check if the folder exists, right? That's what we're doing. Yeah, so if it doesn't exist, because we don't have to create the folder because LlamaIndex will create that for us. So if the folder doesn't exist, if the storage folder doesn't exist, it means we haven't persisted, created the index yet. So let's do that. But if it exists, so this is the new code here now. We'll say storage context. So this is something that we haven't used yet. And then from default, whatever that is, persist there is our storage there. Then index, storage context, and we'll load the index, load index from storage. Go. Okay. That's it. And then down here, we can just return the index. All right, perfect. And over here, we'll just say load index, data there is data, and we have the index here. Yeah, so this is the same. So I'll just double check that this works. I just want to make sure that this is set to info, so we don't get the verbose output there. Yep, perfect. So this works. So this was first call. So we have the storage here, and you can see that This is how the embeddings look like. It's just a bunch of numbers. And then they add a bunch of references, right? There you go, like metadata, right? That's how this is something that you can then retrieve later on if you want to. At least I'm assuming, at least you can do that with LangChain and BetChain, right? You can then pull this as, I think they call it citations or something, and you can say, by the way, here's where the answer was coming from. So there's a bunch of other stuff here, but yeah, we're not. There should be a black box, right? So it's just storage. All right, so yeah, so if we rerun it again, I think it should be faster, a little bit faster. Well, at least we won't see the embeddings calls anymore, right? Because we already have the embeddings. There you go, right? Oh, why is still? Oh, it's embedding the query, maybe. Weird, but it is faster, right? And we can see that it's loading all indexes, right? All right, so let's look at the high level concept. So this was fairly, I think it was easy to understand, easy to come up with. All right, let's go here. High level concepts. So I read about RAG before, right? Like when I was doing the other videos, but I feel like the more I read about it, I'm gonna remember it more as well. So high level concepts, yep. So RAG, yeah, trainer a lot of data, not trainer your data. So RAG solves this, adds your data to the data LLMs already have access to. So the data is loaded and prepared for queries or indexed, right? So that's what we've been doing there. This context and your query. So the context being, yeah. So it is two-step process, right? It's well, we can look at it in the image here, right? So an index is created. You make a query. That query is ran against the index to find the most similar uh, um, chunk of the data that you embedded, right? The data that's in the index. And then you see the prompt, the query that you sent, and the relevant data, not whole data, right, is sent to LLM, and then you get back the answer, right? Yep, RAG techniques, you want to do that. Like LLMs are useful, but they are even more useful if you can plug in your own data, right? So stages, so there's 5 stages. Loading, so getting your data from where it lives into your pipeline. So this is what Llama Hub does. So I have it open here. So let's see. Interesting. So they did, are these like separate libraries? Let me click on it. Download. I guess not. I don't have to. That's nice. I don't have to like hopefully, I don't know. I don't have to download like extra files or something. Yeah, and it looks like it's this download loader. Oh, this is really nice, right? You can so it's tool in LangChain. Yeah, so it's pretty nice. Yeah, PowerPoint. Yeah, all the different sources that you want to have. Slack, even, right? You can point it at your Slack. Make Slack messages as your data source. Let's go back. So loading and then indexing. So this is where you create the embeddings. So it creates a data structure that allows for querying the data. So this is these are the embeddings, the vectors from the data. So this is basically the numerical representation of this text. That's what it is. Yeah, creating vector embeddings, numerical representations of the meaning of your data, and numerous other metadata strategies to make it easy. Yep. And you have to store it somewhere, so you don't have to like repeat this. Remember, this step here, this costs money. cost tokens, I guess, on OpenAI or whatever you're using for creating embeddings. Querying. There are many ways you can utilize LLMs, structure. Okay, and this is just a way of how, like, this could be very simple, but this goes back to this one, the querying. How is that prompt set up? Remember when we were looking, let's see if I can find it. There you go, right? So this is how, in this case, it was very simple, right? But there was this system prompt, right? That was giving like high level information, what the GPT is about and what it should do and what it should not do, and then the user. But you can imagine this being, in this case, it was just one message. It was the system message and the user query, but there could be multiple steps, right? You could have, let's say, since I have videos, right? Multiple video or podcast transcripts. And what you could do is you could maybe, as a first step in this querying stage, you could say, well, go and summarize each one of those podcasts, whatever it is, right? Each one of those transcripts, and then come up with a summary of all, like from those individual summaries, come up with another summary that summarizes whatever you already summarized. So that's like two steps already, right? And then the third one would be answer the question or something like that, right? Yeah, so subqueries, multi-step queries, and different strategies, and an evaluation. I haven't looked into this one yet. This is definitely interesting because it would tell you how, like imagine you come up with one prompt and then you get an answer back, and then you modify the prompt a little bit or change it, and you're going to get a different, maybe better answer back. How can you like evaluate that? How can you say this one is better than that one? And if you can do that, you could. And if you can do that, if you can do it quickly and in an automated way, you could basically like test your prompts dynamically. Like you can run, well, let's say this thing, right? You can run this query with a modified prompt multiple times, and then if you can evaluate each one individually, you can pick the one that's the best, and then return that one to the user, right? So that's pretty good. It's almost like unit testing it, like you want to run it and make sure that it's passing, right? Whatever passing means for you. So concepts within each step. So nodes and documents in the loading stage. So document is a container around any data. Okay, so we've seen this when I printed out the documents object, this guy here, right? And then a node is atomic unit of data, represent a chunk of a source document. All right, so documents, high level, and then chunks within the document, multiple of them. Nodes have metadata, and that relates them to the document they are in and to other nodes. Okay, interesting. Yeah, so you can link them together. Connectors, often called a reader, just the data from different data sources and data formats. Okay, so this is whatever was on Llama Hub there that we see. Indexing stage. Llama will help you index the data into a structure that's easy to read, and generating vector embeddings, vector store. Pinecone is one of them. For example, ChromaDB. And then embeddings, numerical representations when filtering your data. Yeah, so when filtering your data for relevance, so we saw that in one of the outputs. I think it was up there. So embeddings. There was like relevance. I think it was called relevance score or something like that. I can't scroll more, but relevance. So the LlamaIndex converts it in queries into embeddings, and your vectors will find the data that's numerically similar to the embedding of your query. Data. Okay, yeah. So you basically have, if you think about, let's say you have data that says weather is sunny, whatever. So you create embeddings out of that, and that's like bunch of numbers, right? But then you also have a query that says, what is the weather like, right? The weather like. And you can have multiple of these, right? Weather is sunny. I just make it like this, right? Sunny. I'll just make it up. It's snowing on Monday. Whatever, right? And you get different embeddings for these chunks of text. And then you say, what is the weather like, let's say on Monday, right? So we're more specific. So LlamaIndex will convert this query embedding, whatever, just some numbers, right? It'll convert the query into an embedding as well. And then what it'll do is it will search the data embeddings and see which one is the closest, the most similar to, right? This one would be, in this stupid case, right, most similar to this one, right? So it will return you like similarity, right? Yeah, it's actually this cosine similarity, right? It'll say 0 point whatever, right? Some long s number for the first one, right? And then for the second one is going to be higher, right? So that would be, let's say 85, whatever, right? And then you would basically, once you have this, you know that this is your context, right? And then you use this, right? Pick this and say, well, this plus prompt, so I'll say this, prompt plus this, which is context, right? Plus user query, right? Which is what is like, what is the weather like on Monday? And then this goes to LLM and then LLM response, right? If I'm understanding everything correctly, this is how it is. All right. Querying stage. So retriever defines how to efficiently retrieve relevant context from an index. All right. So this was this. The retrieval strategy. The retrieval strategy is key to relevancy of the data retrieved and efficiency. Yep. Router, this is new. So router determines which retriever will be used to retrieve relevant context from the database. So router retriever, selecting one or multiple candidate retrievers. And then there's a selector. All right, so this is more like there's more involved here, but let's look at the retriever. Fetching the most relevant thing, build on top of indexes, but it also defined independently. It's used as a key building block in the query engine. So retrieving the context. So we did this. Actually, let me do. Whoops. Let's comment this out here. So retriever. So you can also, instead of getting it as a query engine, let me comment this out for a second. We can say retriever is index. So get the index as a retriever. And then you can get the nodes, and we'll say retriever. What is this video about? Retriever retrieve. So let's print the nodes out. So let's see what we get here. There's the score. So it's loading everything. So node with score. Embedding is none. Well, it's kind of like we only have one, right? Like I only have one file, so it's not really like relevant or makes sense here. But if we had multiple, we could get something else, right? Actually, let's do it this way. Let's move Paul Graham back and I'll delete the storage. So we'll recreate the embeddings. So let's do that. All right. So, okay. So now we got, why was this cut off? Whoops. Let's rerun it again. There you go. So score 0.74, and this is for the that essay, and then 0.743. So let's see. Oh, this is the essay as well. Interesting that it only like used this one. I didn't get any from the video, right? Actually, let's change the question because it's kind of we'll say what is kind, because that's what the video is about. Let's do that. Interesting. It's still looking at the, let me see, Paul Graham. Oh, there you go. So this is the so 78. This would be, yeah, so this is another one, right? So 078, and this is the kind video, right? The video. Interesting. Why does it do? This looks like a bug or something, because this is not the Paul Graham essay, right? Like text is clearly from the other file there, from this file. Oh, maybe it's node with score node. Maybe it's just the formatting and it's hard to read. Let's see if we can do. There's multiple of these, right? So let's do for node in nodes. Might be easier to read this way. Oh yeah, perfect. This might be better. So one node. Yeah, there you go. Right. So this is, it's clearer here, right? So the score here is on the kind video, right? 0.78, and then on the other text is 0.76, right? So this one will get picked because it's a higher score. Okay, selecting a retriever, you can select index specific. You can select the index specific retriever class, summary index. This creates a summary index on top of summary index. All right, so there's more different ways. Retriever modules. Oh yeah, there's more like different strategies on how to do this. Auto merging, simple, yeah, different things. I'm not gonna go into this right now. Otherwise, we'll just spend time on this. I want to go through like high level, go through everything. All right, routers. Okay, since there's multiple different retrievers, right? Now these routers kind of make sense, right? You can basically decide based on some information which retriever do you want to use. A set of choices. Use selector modules. Yeah, selecting the right data source. Whether to do summary, right, or just search. Right. This is semantic search, by the way, here, right, that we did when there's similarity, right? And then multi stuff. So here's an example. So let's see. Simple example of using router module as part of the query engine. Query engine tool from defaults. List query engine. Useful for, oh, okay, summarizing. And then the second one for vector. Whoops. Query. Oh, okay. So basically you create this router query. You create the different like tools, right, or strategies that you want to use, and then you construct your query engine and say, hey, here's the different tools that I've defined and use this pydantic single selector, whatever the default here is, to select one or the other, right? So I'm assuming if your query is going to be something like, hey, summarize this, it's probably going to pick this one versus the vector tool, but that's just a guess, right? Um, Defining a selector, so pydantic feeds and from a single selector, multi-selector. Yeah, so this looks the same. All right. Fairly powerful. Post processors, transformation, filtering, re-ranking logic to the set of retrieved nodes. So these were the nodes that we retrieved. Commonly applied with a query engine after the retrieval step and before the response. How does this look like? Oh, okay. There you go. So filter the nodes. Okay, so you can just say only return. Like in our case, we only have two, so there's not a lot of things. But assuming, like, let's say you have like thousands and tens of thousands of pieces of like data and documents, right? And uh, you could basically say, hey, anything below 0.75 similarity, I don't care. Just cut that off. Anything above is what I want, right? So you would filter it by that and then re-rank it using Cohere. I guess that's like a re-ranking model or something. Query engine. Yeah, just top one, right? Yeah. Okay. Response synthesizers. Response synthesizer generates a response from LLM using a user query and given set of retrieved text chunks. So let's see how this looks like. Simple iterating. Oh, okay, so this is just a way to, once you get the response back, I'm assuming, you you massage it a little bit more with this synthesizer, right, to get a better response back. So let's see, query engine. Oh, okay, so you can have different response modes. This one is setting it to compact, whatever the query was. I mean, nodes or whatever it has, and then synthesize. You can synthesize the response. So index as we can try this actually. So let's see. So comment this out, and we'll. Let me remove Paul Graham and delete the storage. So I'll recreate it again, and we'll say what is this video about. But over here, we'll create this response synthesizer. Index as, okay, so over here, we create the response synthesizer. Let me get this and import here. So response synthesizer context. Oh, okay. So you can even like modify the prompt template. So let's see how. Let's see. So you can pass in some. No, this was the wrong one. This one, right? Template for summarization. Template for refining. So response mode compact is the default one. I don't know what the others are. Oh, there you go. Refine, and it explains what that is. Compact, simple summarize, tree summarize, generation, no text, accumulate, compact, accumulate. All right, so we can try. We can do generation. Let's see what that one will do, right? It's probably not gonna know. Let's go back. Yeah. Okay. So we do oh, generation, right? Was one. And then over here you would pass it in as query engine, oh, response, synthesizer, basically telling it, hey, use this when crafting the response. And this you could also, I guess, the fact that there's like a templates here, you could probably modify whatever we were, like I was showing it earlier, that system prompt or something like that. You could probably modify it with this, I'm assuming. So let's see what this does. Yeah, there you go. Right. Because we said generation, and what generation does based on the like comments here, it just ignores the context, right? Which kind of doesn't make sense. Return the retrieve context nodes without send. Okay, so let's try no text as well. Oops. Let's try no text as well. See how that looks like. I'm assuming I'm just gonna get back the context. Oh, retrying. Oh, I got back none. That's good. Anyway, um, yeah, this one is explaining what it is. That's the default. Tree summarize, simple summarize. There you go. Simple summarize. Let's do. All right, that's looks similar to what I got with the compact, right? But I'll be curious to try this. So let's do try the um, evaluate the different responses using different response modes, I guess. Oh, and you can create your own like synthesizer as well, right? Just base it off this class, I guess. Oh, there you go. Custom templates. Yep. Yeah, in a tone of. So you can say in a tone of. Oh, this is interesting. Let's try it. So let's do this. Prompt template is coming from LlamaIndex. Template. So given, all right, so this is the same, right? Please answer in the tone of, and then we'll fill that in. So create the prompt. So summarizer is going to be, so summarizers is going to be tree summarize, and that one is coming from response synthesizer. This guy, and summarize, and we're going to do what? We'll make it verbose, and oh, we're basically changing the template, right? Okay. But how is it gonna know? Wait, so response synthesizer will have to be this one, right? Not this. So we'll comment this out, right? We have to use the query engine, right? And then summarize, pass that in as response summarizer, because this one for some reason is getting it directly from the summarizer, but summarizer doesn't really, there's nothing tying it back to the like index, right? So query, but how can we query bundle? So query string, custom embeddings, and oh, interesting. Oh, maybe there's like get response. I don't get it here. How would it need? How does this know which index to use, right? Uh, so let's see. Query component. Retrieve, synthesize. What does this one do? Nodes, no. Get prompts, no. All right, well, let's try what do we get if we do this? Summarizer, get a response, get tree. What is this text? All right, so this would be the context then, I guess, right? Yeah, I think so. Yeah, okay. But we could. Will this work? Actually, let's try this. The only thing that I'll replace this here and say in a tone of spear shakes. I can't spell. Play. There you go. Context query. Okay, let's see. I mean, we should see right away if it's working or not. Oh, yeah, it does. Oh, wow. It's very, very verbose. Hark, the video doth speak of kind. That's interesting. Yeah, awesome. Yeah, so it does work. The only thing that this gets us is you could pass in the variable like this, right? But you could figure this out in a different way. Please also answer in a tone of a 5-year-old child. This is going to be interesting. All right. This is pretty nice, but I think I saw this with special computer system called loading special pictures. Oh, this is probably Docker image, right? Special pictures into computers. Special tool. Nice. Tone of a dog. Let's see. Anyway, yeah, I've seen this in LangChain. So many chains. Oh, there's no dog, but anyway, yeah, makes sense. Let's go together, putting it all together. Move to the next one. So endless cases, query engine, end to end, allows you to ask questions, chat engine, so back and forth, right? Yeah, and then agent, automated decision maker powered by LLM that interacts with the world through the set of tools. So tools are an interesting beast. I might just do like a separate thing looking on like into tools specifically. Yeah, because the idea, if I understand it correctly, like behind the agents and tools, is that you define different, like think of it as a toolbox, right? Like you have a toolbox with 15, 20 tools in there, and then depending on what job it has to be done, you know that you're gonna either pick a hammer or you're gonna pick a screwdriver. But right now it seems like all we have is a hammer because we're always just doing the same thing, but or using the same tool rather. But let's say you, like this example shows, a Wikipedia tool. You could have a translation tool. You could have a tool that looks at the articles from, I don't know, your favorite media outlet, whatever that is, right? Like different tools, and then describe. I'm assuming it goes off of the description, right? You describe what the tool is about, and then based on the query, the agent would know which tool to pick and when to pick which tool. You would basically telling someone, hey, you have these 5 tools available. Here's what I want you to do. And then that agent is smart enough to pick and select a correct tool, one or more, I'm assuming, right? One or more tools, and then knows how to uh, get the responses back, how to interact with that tool, but also knows how to then, or you have to tell it maybe with the synthesizer how to get back the information or return the information back. Yeah, so this is the doing like the Wikipedia, right? Create the agent with load search tools, open it from tools, load search from defaults tool. Yeah, so this agent would know how to use Wikipedia, for example, right? But imagine where you would define like, or you would have like a marketplace of these tools, and you would just say, hey, I want a tool enter agent for this, and this. I want to use those, and then all those together will solve my problem or whatever you're trying to do. This was similar to, reminds me of what was that video that I did? It wasn't last week. It was a couple of weeks back. Let me check. In case anyone wants to take a look at that one. Meta GPT. So Meta GPT. That was the deepwisdom.ai. Yeah, it's a multi-agent framework, right? So there's a framework for this already, right? That would know how to use these different tools together. So it was an interesting one as well. I didn't look very deep into it though, but anyway, all right. So this was high level concepts. So we went through high level concepts. Let's see what's on the left side. So there's customization tutorial. Start with code. Yeah, this is what we did, and then how to customize it. Okay, so I want to parse my. All right, so this is where it goes into. This is an interesting, like useful page, right? Because it shows you how you can customize it more. So I want to parse my documents into smaller chunks. Bundle of services and configurations. So load data. And then you can say, all right, so let's comment this out. And we'll try setting this up here as well. So when we're vector index from documents over here, you can pass in the context, right? But we could create like service context here, right? Service context. And this is from here. Service context from default. And then you can say the chunk size and overlap. Yeah. So this is basically you're saying, I want to, like, let's do this, chunk size 500. And I think what this will do is this will just, I think this is 500 characters, I think. It will, like when we create when we load the data, right, and we try to create the index, what it's going to do is it will split that text into chunks of 500, and then you can also do like the overlap if you want to, and say, hey, I want 25 characters to be overlapped. So it's going to do chunk of 500, and it's going to overlap it by 25 characters. The next one will start like 500 minus 25 at that index, and then it's just going to do that, and then it's going to encode or embed rather those chunks. Right? So let's pass it in here. And I think there's, let me see, Pinecone, chunking strategies. Yeah, this is an interesting article. I'll paste it in the comments if people want to read it. Yeah, so this one will tell you like what are the different like chunking methods, modes that you could use for different I guess based on based on the data that you have, right? Yeah, how to figure it out, right? And then evaluate, right? How you can test what is 500 a chunk size of 500 good, or should it be more or less, or what is the overlap, etc. But this, I don't think it's going to give us any different answers, right? It's just a matter of how many chunks will it create, right? Yeah, there you go. Yep. This, yep, and then everything is the same. I want to use a different vector store. This is interesting as well, right? So this is, you can use Chroma or Pinecone or whatnot. Let me see how it looks like. storage context. So storage context from defaults. Oh, and then instead of like storing it on disk, well, Chroma stores it on disk as well, right? But you can pass in the vector, the actual instance of the vector store where your data is, right? So instead of storage, checking for the folder here, we would check if this vector store exists or not. Yeah, this makes sense. From documents. Oh, and there's storage context as well here as well, right? Oh, you would create the storage context and then pass it in. Right? Yeah. So instead of doing storage context from defaults, we could do, right, we could do this, right? We say storage context. If we refactor a little bit, right, we could say, leave it like this, right? Go, and then we don't need this, right? But over here, we would say storage context equals storage context. Just make it like this. It's easier to read. This should still work. The only thing that we've done is we just extracted, refactored it out a little bit. So now if I want to use, instead of the folder, I want to use, let's say, Chroma DB. So we'll say get Chroma. Chroma store, we'll call it that, right? And then we'll use this. Just paste it here. And I think I need these two. Probably need to install Chroma dependency. Yep, so pip install Chroma DB. Come on. Okay. Should be. There you go. And we'll say collection name equals videos, right? Why not? Collection name. I don't need this. And then we'll just return the vector store here. And then over here, instead of doing persist, right, storing it to the folder, we would say vector store equals get Chroma store. There you go. And this should switch. I think this doesn't make sense now. So let's see. Chroma store. This. Yeah, this one doesn't make sense because like we're not looking at the existence of the folder anymore. We would have to see if, let's see if there's an easy way to, well, we can just fill it out multiple times. Doesn't matter, right? But you would check here to say create collection, maybe like Chroma client, say get collection, right? Yes. Get collection, name, embedding function returns the collection, raises an error if the collection doesn't exist. So we would say collection name. So we could try. So if this one fails, right, we will create the collection, right? So we do something like this. There might be another method. I mean, this accept, probably not a good way to do it here, but might be a better way. Oh, there you go. Has collection, was it? Oh, there you go. Oh, that makes sense. Is there a has collection? No, it's not. It's Copilot lying. Count, create, delete, get. Oh, get or create. Yeah, that's what we want, right? Get or create, collection name, and Chroma collection. And we don't need this. So this will either get it if it exists and create one if it doesn't. But I don't know if this fixes anything for us because we don't have to do this if the data is already there, right? So we would say, do storage context. What can we do here? So persist vector store class. Storage context. So this will persist the chroma store, I'm assuming. Just need to figure out how to, let's do a simple one. So we'll say chroma store collection. So get wait, how do I wanted to check chroma count. That's what I wanted to check, right? I wanted to check if there's 0, right? Then load the data. If it isn't, don't load it, right? So say chroma store add delete all JSON. Let me see if there's no. There has to be a way. I mean, I could. No, I can't access this one because it's private. Client. Yeah, but this one isn't. Anyway, let's do. Let's do this in here. There you go. Yeah, let's do this in here. So we'll say chroma client collection name will be videos, and we'll say chroma collection dot count. I'm assuming this one will return the number of embeddings, and we'll say if this equals 0, we haven't embedded anything, then we have to do this, right? Then we load the data, load the documents, storage context, we can create it here, right? Chroma store, we don't need this. Do collection, chroma store, whoops, this one, create the storage context, check if there's nothing in the collection, do the indexing and embedding, right? And then we're going to persist. Otherwise, we'll load it, right? So this is the same. I still think there's an easier way to do this probably, but for the sake of time, let's just do this. So load index, this is now going to use, we don't use this storage there anymore. I'm not using this one. All right, so this should still work. Oops. It should work, hopefully. Yeah, so we get the response back, same as before, but this time, see, we get the chroma folder because we're using chroma as our vector DB. All right, so that works. I want to retrieve more context when I query. This is good. So instead of like getting the top one, in this case, we could get like 5 top. Remember the similarity and the score that I was showing? You can say, well, not just the first one, give me like the top 5 of them. Oh, I guess the default is 2, right? So I want to use a different LLM. Makes sense. Can use the local one, whatever you want. And then how do you do service context? context. Oh, okay. So it's all in the service context. So when you set the chunk size and all that, you could also set the, yep, you can set the LLM that you want to use. I like it. I like the way that it's like set up. For some reason, I keep forgetting the name. The LangChain feels more complicated, I think. I don't know. This one feels simpler. Different response, and I like these different things because these are some of the things that you will probably do. Oh, you can stream. Nice. This is nice as well. And it's very easy. Look at that. Just do true, and that's it. Where were we? Down here, right? Index as query engine. Oops. Let's go down there. Let's try streaming. Streaming equals true. And then print response.print. All right, so you do response.print response stream. Nice. Let's comment this one out. Oops. No index in the storage context. Oh, this is running its second time around. Oh, do we have to persist there? Chroma? Maybe? I don't know. No. Bleh. All right. I guess it didn't work, whatever I was trying to do earlier, but let's just like, it's, what time is it? Yeah, we're almost done anyway on time. So I'll just re-embed everything again on the next retries. But, I don't need this. Should work now, I think. Yeah, there. But now we should get streaming responses. Yeah, there you go. That was very short though. Streaming response. Okay. Chatbot as chat engine. And then you can go back and forth. Oh, that was it. This was a useful page. LlamaIndex. Oh, they have videos as well. Nice. And with the notebooks. Perfect. Q&A. Types of questions, where research, how, yep. Yeah, there's a lot of stuff that I didn't go through, but I feel like there's a lot of things. This looks very interesting. Full stack projects, SEC insights, okay. RAG repo, chatbots, agents. Yeah, I guess this just goes more into the I like the documents. I like the documentation here on this one. Pretty good. All right. Anyway, well, thanks everyone for watching, and I'll see you next week. Bye.